Got a very good presentation here describing how Las Vegas migrated from the 1.3.3 core to the XchangeCore 2.0 for a very specific reason, and that is they have a quantity of information that comes from the Tritech computer-aided dispatch used by the fire alarm office that sets information out for all fire and emergency medical response in Clark County. And Las Vegas wanted to get certain portions of that information. As you'll hear from Jason Ellington and Richard Wells, the developers of this, we are providing a new way to do that through the virtual cores. So what our topics for today are going to be is that I'm going to give you a little bit of overview of virtual cores, which take advantage of the intra-core agreements established by the new XchangeCore 2.0. And then Richard's going to talk a little bit about why they moved to XchangeCore 2.0. And then we'll hear from Jason, who actually is not here, but he recorded a couple of minutes describing what he did as the programmer to build the XchangeCore connector. And then we'll come back to Richard, who will describe how he built the virtual core and created the agreements, which we did all because we can't show you their real operating system. Richard's done it here with the XchangeCore test cores and support from the XchangeCore staff where necessary, so that he has a complete working parallel here in a test environment, and now we'll be moving it over into his real-life environment, which you're not going to be able to see in the future. So we're getting a real nice peek into what Las Vegas is doing. And then we'll take a final look at their future directions, and then we'll have our open mic call. So with that as introduction, let me take you through a little bit of a view of virtual cores and the intra-core agreements. So before XchangeCore 2.0, in order to accomplish a peer-to-peer exchange, you had to have multiple machines. Each machine had a core, and as you see here, I can have lots of people connected, lots of applications connected into the core in that hub and spoke format that you see the 5, 6 different representations of there with XchangeCore in the center. So those are applications connecting into XchangeCore. Where I share between cores or in multiple core-to-core sharing, represented by the dotted lines, those required physical machines and worked very effectively, but as the world has gone virtual, the XchangeCore 2.0, which was largely funded by the Department of Defense in their move to using XchangeCore for situational awareness sharing, this adaptation of the original core design allows us to create virtual cores. So now a single physical core is virtualized. So we still have all those different applications in a hub and spoke format, but now you can begin to group them together in order to create a virtual core. I'm going to give you a couple examples on how that happens, because you write rules associated with the exchange of information inside the cores. And those rules start out with the first one, just like they always did. You can share anyone to anyone in the core. So where that dotted red line crosses those little blue lines, that indicates that those people can all share information. So nothing different there. You can make on 2.0, you can do exactly what you've been doing on 1.3.3. Second type of rule, though, is where specific applications exchange. I can say anywhere in this core that application up in the upper left-hand corner is only going to touch and talk to application down in the bottom right-hand corner. Those two up in the upper right-hand side, those two are going to talk. So it can create a very specific application-to-application sharing, which is very nice when you're trying to get some specific applications that need to work their way through XchangeCore. And in a sense, that one-on-one exchange, if you divide half of what Richard has done, you're seeing a sharing of information between two different applications. But we did more with that with XchangeCore and Las Vegas, because what we did was create groups. And one of those groups only has a single entity in it, but what that does is allow within groups you to establish a sharing within a group and then a sharing across the groups as well. So what you're going to hear is one of these green triangles represents the fire alarm office. That information is then shared and made available as that group. On the other side, the other green triangle is represented by two applications used out in Las Vegas, SpotOnResponse and WebEOC. So those two also represent a group. So fire alarm shares to the combination of WebEOC and SpotOnResponse. Third type of, or fourth type of group allows you to combine it all. Combine specific applications, specific groups that share with each other, the exchange among groups to allow you to establish that set of sharing, all of which produces the ability to pretty much meet any type of an information exchange concept of operations that you have. You can have up in the upper left-hand corner a single core deployed with a hub and spoke environment. That's as far as you go. But you can establish inter-core sharing on a peer-to-peer basis to another physical core with a hub and spoke out there. So you can do it exactly the way we always used to do it. Horizontal red line says I can still take that single core, connect it out to one of my virtual cores, and have all of that intra-core peer-to-peer exchange going on between applications or between groups or whatever it is that you want to have. And at the same time, all of that can go to multiple virtualized cores. So you have intra-core peer-to-peer, cross-core, physical core, peer-to-peer, within a single core, the hub and spoke relationship to bring everything in. So with that design, as confusing as it appears to be, you can't find any, I defy you, any information management concept of operations where you want some people to share, some people not to see, some people have a secure exchange between each other, others that are sort of a public exchange out to a number of different organizations, some that only go specifically up to a state organization, others that are available out to all the different counties. Defy you to find one. If you do, I would love to take the challenge to see whether we can't match that information exchange concept of operations. The bottom line of it, though, is that this concept of deploying these regional or virtual cores hugely reduces the operations and maintenance costs of information exchange, because you can virtualize the core. An entire state could establish a set of virtual cores, and they would be able to be deployed out for all the counties. A FEMA region can sit there and say, okay, I got 8 states in my region. We're putting them all onto a single virtual core. So the ability to reduce the operations and maintenance costs is one of the key reasons for doing this. So let me invite Richard now to talk about the objectives that Las Vegas had in moving to XchangeCore 2.0 and managing the information and being able to better control it in Las Vegas. So Richard, please.
Oh, fantastic. Thank you, Jim. One of our first objectives was to, obviously the fire alarm office has a substantial amount of call volume coming in. So we were looking to select just those appropriate incidents that would be relevant to our mission here in the Office of Emergency Management. Given the nature of the calls, it was obviously important to protect privacy and to make sure that this data was only being shared amongst the emergency management community. And then again, like I stated, we were just after those calls that were important to us. So a great deal of the medical calls were not really of interest to emergency management. We were looking more for the fire calls and then select medical calls that we identified. And then finally, we didn't want to duplicate the effort or create any conflicting command, meaning there's other data sources there's other clients that consume data from the fire alarm office, like Pulse Point and First Watch, and it's real important that the Tritech system is the authoritative source of data from the dispatch center, that we're just pulling out information that's useful to us. So that's why we went this route. And in this process, we obviously understood that dispatch technology is fluid, it's changing. So we learned that codes change due to software upgrades, due to real-world events, due to different incident types being retired, all kinds of reasons for that. And then most importantly, the codes are not, we don't control the codes. It's, the fire alarm office is a collaborative effort between the City of Las Vegas, City of North Las Vegas, and Clark County, Nevada. So they are the ones that determine what those codes are. And then finally, dispatch is obviously burdened enough with their mission, so we didn't want to put any additional constraints on having them have to take extra steps to notify us when certain incident types occurred. So as a result, we looked to just control the process for us within our office. And by creating the virtual cores, we're able to pull all the records over and then again just pull out those that are useful to emergency management. So I guess it's important to note that the virtual core allows us in the Office of Emergency Management to determine when that data is shared and with whom. So through this process, we're able to pull out, again, those records of interest and pass them to our emergency management partners through tools like the WebEOC, through ArcGIS Online, tools like SpotOnResponse, et cetera. So those are our objectives in going to the virtual core.
Great, thank you, Richard. Now, moving over to the next look, we're going to take a look at how this development process took place. And Jason Ellingson, the City of Las Vegas, did all of the coding for this. So this is this is a very good example of internal resources being applied to be able to carry out the development of this. And so I mentioned Jason is on vacation this week, but he has recorded a couple of minutes here to describe what it is that he did, and a couple of slides that are here. The first one simply representing code. So let me pop up Jason here, and let's
start the City of Las Vegas XchangeCore project by reading the online documentation available to try and get a feel for how the software worked. Once I was comfortable with that, I downloaded the source and example code that was available. Going through the example code helped tremendously. I was able to get a feel for how to insert, update, and close records. My first order of business was making sure I could actually put data into the core. It took several attempts, but I finally figured out how to do it. From there, it was a few more attempts to do an update, and finally I was able to close the record. Next, I set up the field alarm office side of things. As I'd find out later, this caused more than a few problems, as the data coming from Tritech didn't match what XchangeCore expected. To get around this, I created what I called CLV incident intermediate objects, which had methods to transform the data as necessary. These objects also held the incident status, so I'd know if it was new or already existing on the core. Finally, I needed to figure out which incidents already existed on the core. Once I figured out how to retrieve incidents from the core, I was able to bring back Tritech data using a combination of those incident IDs combined with the last run timestamp. This gave me both new and existing information. And with that information, I was able to update the status on my CLV incident objects. With all the data in the correct format, I simply looped through each CLV incident object checking the status. If it was new, I'd add it to the core. If it was existing, I'd check the close date time field on the record to see if it contained a value. If it was blank, I'd update the record. If it contained a value, I'd close and archive it in XchangeCore. Using this method, we were able to easily pass Tritech data to the core at whatever interval we wanted.
Jason very nicely and succinctly describes this entire connector operational process from a development standpoint. And I think his experience was a very valid one. He was supported from a technical standpoint by asking questions from the XchangeCore community technical team. But principally, he grabbed out of GitHub, he grabbed all of that example code and was able to work his way through it and really do an excellent job. So with that said, let's turn it back to Richard, who is going to take us through the 4 steps that we go through to create these virtual cores, beginning with the users, then the cores themselves, and then adding the users to the cores, and then finally creating agreements. So Richard, I'll leave this to you now.
Oh, great. Thank you, Jim. So using the XchangeCore server hosted by Jim and his team, we were able to successfully map out 2 virtual cores to facilitate the sharing of Fire Alarm Office data. So although somewhat technical, these steps illustrate how easy it is to tap the ability to create multiple virtual cores on one physical machine. So let's look at the first step, create users. In the drop-down menu, once you're on the management console for the XchangeCore, groups and users, we would click on. And then again, we're creating a new user. So we select that option. And then we'd enter in the information for the account name and then set up a new password. And then upon successful completion of that, we would have added a new user. So in this case, we added Smith J as a new user to our core. So now on the left there, you can see all the users that we have available to choose from which to add to a virtual core. So you can see there at the top the record that we had added, Smith J, along with the others. And then down below you can see the Fire Alarm Office core and the LVEMA core, virtual cores. Okay, so the next step was to create and rename the groups. So going into the program files, we opened up this XML file and change the names. So as a default, the virtual cores are created as vCore 1, vCore 2, etc. So we wanted to go in and give those names some personality to keep track and to better control what we were dealing with. So this next step will show you that. So here you can see in the security rule, we changed the name from vCore 1 to Fire Alarm Office. And then down below, you can also see where the next one was changed to LVEMA. And again, this is optional. If you want to stay with Virtual Core 1, Virtual Core 2, you can do that and just leave this unchanged. Okay, and then our next step was to link security rule to the roles. So again, just going in and changing that information. You can see the role that is for the Fire Alarm Office and then the information Fire Alarm Office entered in there. So it is a security role, and if we had changed the role name, we obviously need to change the rule to match. Okay, then finally, we're ready to create a new virtual core, a new group, and add our members. So here you can see the group name. We're going to call this first one Fire Alarm Office, and we're going to select the group members that we want to have access to that virtual core. So in this case, Jason, the Fire Alarm Office, and Dr. Morentz are added as users that we want to be part of this virtual core. And then there's the second group, the LVEMA, and again we have the ability to select group members. In this case we're going to give Dr. Morentz again, SpotOnResponse, and WebEOC as members of this core. So the next step, agreements between virtual cores, we could either use standard incident types, which everyone's familiar with, earthquake, accident, bomb threat, etc., and or customized incident types. So because we are working with data coming from the Fire Alarm Office, we have to use custom incident types. And I guess it's important to note here that we did not use the ability of the virtual core for proximity sharing. We hope to tap that later. And we also did not use the extended metadata sharing at this point. We had to create agreement rules to define how the data is going to be shared and with whom. And so here's an agreement based on incident type. You can see the call records there on the left that say fire alarm incident and then what the information is. And then you can see on the right-hand side where below it says incident type 9D cardiac arrest. So specific codes are, again, not part of the standard incident types. They're custom incident types. And now after this part, we needed to call on Jim and his team to help us a little bit with the JavaScript to make sure that we were doing the personalized incident types correctly. So they had a good set of instructions and kind of helped us along with this process. So the incident type JavaScript file we edited, and here you can see where we insert, well, where the circle is where we would insert the records for our custom incident types. So what you're seeing there, you're looking at the standard incident types, and we'd make an entry into there to insert our new custom incident types. And then the result of that is you see the enable rule down below, and you see all our incident types. So there's an example of some of the incident types that are available to us coming from the fire alarm office. So this is our personalized incident type list. Okay, so now we're ready to create sharing agreements, and you can see where it says create new agreement from which core and with which core, and then a description. So we're going to do that in our next step here. So the first step is to define the exchange. So this is where we're defining which virtual core incident types are shared from which core and who they are shared with. And the next slide here will show us how we accomplish that. So here you can see sharing from one group to another group syntax. And you can see for Las Vegas down at the bottom of the slide, the fully qualified domain name. You can see the test server, and at the end there, what's important is the group name, Fire Alarm Office. So that's the from, and then with is the next line, LVEMA. And again, this is just on the test server where we were fleshing out the concept, not our operational environment. And so again, here's the slide that shows that information entered in there. So from the Las Vegas Fire Alarm Office with the Las Vegas Emergency Management Agency. And then just a brief description. And then again, you can see the incident types where it says enable rule. Okay, so the next slide shows us how to select incident type and add to rule. So we'd click enable sharing and add a new rule, and then we go down and select the incident type that we were interested in sharing and add those. And what's important here is that we can add as many rules as we want, and we can disable them or remove them at any time. And then the end result is we have one physical machine with many virtual cores, and again, that ability to segregate that data that we're interested in. So we're pulling over all the fire alarm office records, but we're only culling those records that are of interest to the emergency management mission. And then we're able, through that process, to share out via WebEOC or SpotOnResponse or ArcGIS Online those incidents with our emergency management partners. Okay, Jim, I think that's it. Okay.
Well, what we have are a couple of slides here that we're going to skip because we have the actual real things up here, and we wanted to have slides available just in case there wasn't anything happening in Las Vegas right now, which is probably unusual. But here's that management console that Richard was talking about. And by the way, great explanation, Richard. Appreciate that. So if I come over here and take a look at the incidents and work products, and what I've got are a whole bunch of them. Actually, let me come in here and it says show 10. Let's show up to 50. And yeah, we've got a few more there. So a whole bunch of incidents and work products, work products that are there. These are all fire alarm office, and here's a backfall and a sick person and somebody else who's got some specific diagnosis and some pregnancy things that the Emergency Management Agency really isn't that interested in. So what we've got then over here is a SpotOnResponse, and you see we've got these dozen or so incidents that are there. And the only ones that are of any value coming over here as SpotOnResponse are those two. And if I come over here and we've got a WebEOC, here's the WebEOC look. You notice all these that have previously come in, the closed incidents, and the same two that are available over here in SpotOnResponse are here in WebEOC. So there's your perfect example of using the virtual core capabilities let's put that down, virtual core capabilities to take from this whole long list and turn it into this nice tight, USC, we just added a third one there and added a third one there. Hey, you could ask for anything more dramatic than that. So somewhere in here on this side came into that first core that Richard described and built. It evaluated the rules, and both WebEOC and SpotOnResponse in an instant received that updated information associated with the ones that want to move from the fire alarm office directly into the external applications that are used by the Emergency Management Office. So some very, very clear examples there of how this has aided what the process that Las Vegas has put in place. And let me just bring up your slide here with a couple of next steps you might want to comment on, and then we'll open it up for questions.
Yeah, thanks, Jim. Obviously, in our journey to get to version 2.0, our previous core, the 133, we learned a great deal about, sharing information. Dr. Morentz's team has been very helpful to the Southern Nevada community as far as working with this and very patient with us as we take baby steps. So getting this fire alarm office adapter together has been a great learning experience. And now that we have that in-house expertise to develop adapters, and we've proven the concept that we can share information selectively and securely, our next steps are to get additional data sources. So law enforcement is a huge area that we'd like to tap into. So we have discussions going on with the Las Vegas Metropolitan Police Department. Natural hazards, obviously earthquakes, any kind of sensor data out there that could be giving us useful information, we're looking at tapping to where we can really build a very nice blend of different data sources to give us, greater situational awareness here in the Las Vegas Valley.
Well, terrific. Thank you, Richard. Let me open it up for any questions here while I say thank you. Great presentation, Richard, and great work that you guys have done out there. I'm glad we were able to showcase you.
Thank you.
So,
Jim.
microphone is open. Any questions, comments from anybody?
Yes, I have a couple of questions actually. This is Paula Scalinci, Bay Area Center for Regional Disaster Resilience. And the questions are, the first one is what sort of procedures do you use for selecting members to the system and vetting those members? So that's the first question I have. And then the second question I have is, how do you maintain that membership and change out when people leave, new people come in? So how is that handled?
Yeah, actually, I'll answer that one because it's a broader XchangeCore kind of question, and then Richard can add to it specifically. XchangeCore doesn't connect to people. It connects to applications. So the vetting of the people who actually see the information is done by the application owner. So XchangeCore gathered information from the Tritech CAD, shared it to WebEOC, and shared it to SpotOnResponse. It is the application owner, City of Las Vegas, that runs their WebEOC, that's responsible for vetting and providing access to those who use WebEOC. Same way with SpotOnResponse. Whoever has access to SpotOnResponse sees the information that has come in. So the XchangeCore component of it never looks at the end user. It's the connection to the applications, with the application owner then providing access to individuals who they trust with that information, or from whom they want to get related information back into their system and thus into XchangeCore as well. So,
okay, that's great. For Las Vegas, how do you have procedures you've come up with, written procedures on selecting members, vetting members, maintaining the membership roster?
Yeah, Paul, what we do is we have our local emergency planning committee. That is really the venue where we vet those who have access. And like Jim stated, through the WebEOC is really where, if you have access to the Clark County WebEOC, then you're able to access this data. So to get that, you have to go through, again, our local emergency planning committee, which rolls up to the Clark County Office of Homeland Security and Emergency Management, and they administer those accounts on WebEOC. So once you get that account, you're able to tap into that. And as far as a tool like SpotOnResponse, we have been given the ability through Jim and SpotOnResponse to mirror those accounts that are in WebEOC. So that's how we handle that. Okay,
that's great. And you keep the various records from the different incidents when you use XchangeCore. You keep those, maintain those yourself?
We do archive the records, yes, ma'am.
Okay. Thanks. I really appreciate it.
Sure.
Ann, I see you've raised your hand and have a question. Was that true? All right. Anybody else with questions, comments? No. Thanks for your questions, Paula. And Richard, and in absentia, Jason. But Richard, great job. Really appreciate you bringing us up to date on the transition that Las Vegas has made and everything that you have been doing out there. And offer my appreciations to everybody for joining in on the call today. Watch your XchangeCore communicator. Oh, yes, okay. Yes.
Oh, there we are. Okay, hi. I couldn't figure out the audio. So I'm Ann Rosinski. I'm with the California Earthquake Clearinghouse here in the Bay Area. And I really appreciate this presentation from Las Vegas. It's very timely for us because we've been a long-time XchangeCore partner, and we are in the process of developing these types of sharing agreements with some of our partners. And we are going to be, just as a teaser going forward, the Clearinghouse information sharing effort is going to be a component of a USGS project called Haywire that's going to be looking at impacts of Hayward Fault earthquake in the Bay Area and some of the impacts to critical infrastructure, including utilities. And those partners have sensitive information that they need to be able to share and with various partners. So the type of work that the Las Vegas team has done is going to be really important for what we're doing in the next several months. And like I say, I really appreciate the candor in describing some of the challenges because we need to understand that it's entirely possible to do these things, but it does take some thoughtful consideration to figure out the best way to go about doing that. So appreciate the information, and just as a teaser, hopefully in the next couple of months the Clearinghouse will be able to build on some of those capabilities you've developed.
Well, thanks for the feedback, Ann.
Thank you, Ann. And also, we've got Gluckerman is on the call. He has written in a question. If you'd like to speak, I did unmute you, but his question was curious about the API that we're making available to the public so they can get accurate information into the apps, etc. If you would like to expand on that, please feel free to. Otherwise, I'll answer it. Oh, okay. Well, then let me say the API that Richard was talking about comes in a couple of different forms. It is both done in C# for .NET applications as well as Java for Windows Java applications or into Linux environments. And the API fundamentally is described in the XchangeCore documentation that allows you to use an XML document to download incident information and all the other types of information, add information into that XML document, repost it into XchangeCore as an update, and thus begin a progression of exchanges that can take place about incidents, about sensor readings, human sensors, about resources, about personnel and the tasking and the operating procedures associated with those, as well as a whole lot of exchanges related to mapping and GIS information. All those are explained and available on the example code is available on GitHub in the XchangeCore repository. And the API exchanges are all available and described in a series of documents that are available on the XchangeCore.org website that are called Quick Start Guides to Incidents or to Sensors or to Resources. And each one of those describes the exact process and gives references to the example code on how to make that connection between XchangeCore and whatever application is that you want to bring the data in. Some of that, those applications literally are as simple as an Excel spreadsheet that can be uploaded with information going into XchangeCore, to as complex as computer-aided dispatch systems that are working on millisecond response times and require a tremendous amount of error checking and assurance that the quality information is being exchanged, as we saw here in what Jason did and provided to Richard and the City of Las Vegas Office of Emergency Management. So hope that answers that question. And let's see, I don't see anybody else raising their hand on the tool. Let me open it up for any final questions that anybody has. Hearing none, you'll get your next announcement in the XchangeCore communicator of the available webinar that we'll be doing. And I wish you all well. Enjoy the beginning of springtime. Bye, everybody.